In this video, we are going to explain the properties of discrete Fourier transform. The first property is periodicity. Here we have the input sequence x of n. The input sequence x of n is periodic with the periodicity capital N. If x of n signal is periodic with the n, then we can write x of n plus n equal to x of n plus n equal to x of n. DFT of x of n can be represented as x of k. If x of n is periodic with a periodicity n, then x of k is also periodic. So, we can write x of k plus n equal to x of k. I repeat, here we have the input sequence x of n. X of n has periodicity capital N. Then we can write x of n plus n equal to x of n. The DFT of x of n equal to x of k. If x of n is periodic with periodicity n, then x of k is also periodic. So x of k plus n equal to x of k. This is the periodicity property of the discrete Fourier transform. Second one is linearity. DFT of a1 x1 of n plus a2 x2 of n equal to a1 x1 of k plus a2 x2 of k. This is the linearity property of the discrete Fourier transform. Here x1 of k is the discrete Fourier transform of x1 of n. Discrete Fourier transform of x1 of n is represented as x1 of k, and discrete Fourier transform of x2 of n is represented as x2 of k. Therefore, the linearity property of discrete Fourier transform explain that DFT of a1 x1 of n plus a2 x2 of n equal to a1 x1 of k plus a2 x2 of k. Next property is DFT of complex conjugate sequence. We have x of n is the input sequence and its conjugate sequence is x conjugate of n. X of n is a input sequence and x conjugate of n is its conjugate sequence of x of n. Then DFT of x of n is represented as DFT of x of n is represented as x of k. Then DFT of x conjugate of n can be represented as x conjugate of n minus k, where n is the n-point sequence. N is the n-point discrete sequence. N is the n-point discrete sequence. Here x of n is the input sequence and x conjugate n is the conjugate sequence of the input x of n. Then DFT of x of n is equal to x of k and DFT of x conjugate of n equal to x conjugate of n minus k. Next property is DFT of delayed sequence or shifted sequence. Let DFT of x of n equal to x of k. Then DFT of shifted sequence. We can write shifted sequence as x of n minus n0. Then DFT of shifted sequence can be written as x of k into e raised to minus j 2 pi n0 k n0k divided by n. Shifted sequence DFT equal to x of k into e raised to minus j 2 pi nk by n, n0k by n. And this is a DFT of the delayed sequence. Next one is the DFT of time reversed sequence. Let DFT of x of n equal to x of k, x of n equal to x of k. Then the DFT of time reversed sequence, we can write the DFT of time reversed sequence as x of n minus n equal to x of n minus k. Here reversing the endpoint sequence in time is equivalent to reversing the DFT values. This is the property of time reversed sequence in DFT. And next one is circular convolution. If DFT of x1 of n, if DFT of x1 of n equal to x1 of k and DFT of x2 of n equal to x2 of k, then DFT of x1 of n, here we are performing circular convolution, x1 of n circular convolution, x2 of n equal to x1 of k into x2 of k. That means on performing the circular convolution, DFT of circular convolution equal to multiplication of the DFTs. Here DFTs are of x1 of k and x2 of k. So DFT of x1 of n circular convolution x2 of n equal to x1 of k into x2 of k. Then next one is the multiplication of two sequences. Here we have sequences x1 of n and x2 of n. The multiplication of these two sequences. So the DFT of the multiplication of these two sequences x1 of n into x2 of n. The multiplication of these two sequences equal to 1 by n x1 of k circular convolution x2 of k. Circular convolution of two DFTs divided by n, where n is the endpoint sequence or endpoint samples. Here we are taking n samples. So multiplication of two sequences property explain the DFT of x1 of n into x2 of n equal to 1 by n x1 of k into x2 of k. These are the properties of the DFT. Okay, let us move to the next topic, relation between DFT and Z transform. Relation between DFT and Z transforms are going to explain the Z transform of an endpoint sequence. We have the endpoint sequence x of n. So the Z transform of endpoint sequence x of n can be written as Z x of z. We write Z transform as x of z. X of z equal to summation n0 to n minus 1 x of n into z raised to minus n is the Z transform of x of n. To find the relation between DFT and Z transform, we are evaluating the x of z at equally spaced points. Here the equal spaced points are taken as the samples n. So next we are going to evaluate x of z at n equally spaced points. X of z at n equally spaced points on unit circle. Point on unit circle. Here circle z equal to e raised to j 2 pi k by n. That means here performing x of z at z equal to e raised to j 2 pi k by n, which is equal to summation n0 to n minus 1 x of n into z raised to minus n at z equal to e raised to j 2 pi k by n. In the next step, we are going to substitute the value of z in x of z. Then the equation becomes x of z equal to summation n0 to n minus 1 x of n into e raised to minus j 2 pi nk whole divided by n. We can write this equation as equation number 1. Here equation number 1 is the evaluation of the Z transform at equally spaced points on the unit circle. Then we are going to take the endpoint DFT equation. By using the endpoint DFT equation x of k, DFT equation x of k equal to summation n0 to n minus 1 x of n into e raised to minus j 2 pi n k whole divided by n. Equation number 2. On comparing the equation 1 and 2, compare equation 1 and 2. We can see that x of z equal to x of k. That means x of k equal to x of z at z equal to e raised to j 2 pi k divided by n. In the relation between DFT and Z transform, first Z transform of endpoint sequence x of n is calculated. Here x of z equal to summation 0 to n minus 1 x of n into z raised to minus n. Evaluating x of z at n equally spaced points on the unit circle. Here unit circle z equal to e raised to j 2 pi nk by n. For evaluation, we are substituting z equal to e raised to j 2 pi nk in z transform equation. That means x of z at z equal to e raised to j 2 pi k by n equal to summation 0 to n minus 1 x of n z raised to minus n. At z equal to e raised to j 2 pi k by n. Substituting the value, we get equation number 1 as x of z equal to summation 0 to n minus 1 x of n into e raised to minus j 2 pi nk by n. By definition of DFT, x of k equal to summation 0 to n minus 1 x of n e raised to minus j 2 pi nk by n. Equation number 2. On comparing the equation number 1 and 2, that means here we are comparing the DFT and Z transform. We can see that x of k equal to x of z at z equal to e raised to j 2 pi k by n. From this, we can conclude that the endpoint DFT of a finite duration sequence can be obtained from the Z transform of the sequence at n equally spaced points around the unit circle. That's all in this video. Thank you.